Hi class, we are ready to begin a new unit titled the electron along with the periodic table and the trends. So to get started with that, we're just going to get started by looking at our standards that we need to cover. You can feel free to pause here if you'd like to take a look at these in further detail. But mostly we're just going to be discussing the periodic table. We're going to be making sure that we understand how to use this valuable resource. And we're also going to make sure that we understand how to make some electron configurations down the line, as well as learn the different trends in the periodic table. So let's get started. So objective one is to definitely understand about Mendeleev because he is the father of the periodic table, basically. Yes, there were others that were also trying to put some things together, but Mendeleev was the one that was actually credited with the current outlay of the periodic table, partly due to the fact that he was able to predict elements that weren't even named yet, because of he was able to leave blanks, and that was considered a very brave and daring thing to do. And he kind of sat with it for a little while and then figured out later on that he was indeed correct. So he was the one labeled with the father of the modern periodic table. So this was just kind of how he did it at first. He was organizing the table into groups and periods, and we'll look at those in a couple minutes. And this is what our modern periodic table looks like. Okay, you definitely are going to have to make sure you understand these regions, and when the time comes, you're going to come to me and get a periodic table, and you will be coloring in the periodic table to make sure you're understanding your metals versus your nonmetals and your metalloids. And you will also understand on the back side of the periodic table what all of the different polyatomic ions are, which we will discuss later on in the next unit. So let's just take a look at the history of the periodic table. You will get something similar to this in class. Just get it from me. It's going to be a paper copy, and keep it handy because you're going to need this pretty much for the rest of the school year. So looking at this, you have your groups. Groups are going up and down. Okay, so this first one here we consider group 1. And these are actually what we consider the alkali metals. They are reactive in water for the most part, from lithium down to francium. And the further that you go down the actual column, the more reactive with water it becomes. And then if you take a look here at our group 2, these are actually what we call the alkaline earth metals. Now these are also pretty reactive, but not as reactive as, let's say, the group 1 in water. In the center here, you have something called the transition metals. These transition metals have their own special bonding. We'll talk about that later with metallic bonding. But for the most part, you probably recognize many of these, like copper, nickel, and iron, and silver. So these are all here in the transition metal section. Moving over here to group 3, you're going to have, if you're starting to look down this purple line right here, it almost looks like a step ladder. This is what we actually consider our metalloids. And metalloids have the properties of both a metal and a nonmetal. Makes them perfect for things like semiconductors. You've probably heard of silicon whenever we put this in our motherboards and computers. And then over here, whenever these are just other metals. They're not really sure how to classify them, so they just kind of call them other metals. But if you look over here in the pink range, from here on over, these are all of our nonmetals. Nonmetals are what's considered electronegative. They have a high affinity for electrons. They like electrons, okay? All these over here. So these metals over here are positive, and we're going to talk about the types of ions that they form in a little bit. But these are, if they lose their electrons, they're considered positive as a result. And then as you move across the periodic table, which we talk about a little bit later on, it becomes more and more electronegative, which means it has a higher affinity to like and capture those electrons. So whenever we get to ionic bonding, you'll start to notice that what we call our valence electrons, if you were to fill up a shell here with all of these group 1s, they would all have one valence electron in its outermost shell. And then these would have 2 valence electrons in its outermost shell. Moving across, these would have 3 and then these would have 4. We just kind of keep going. 5, 6, 7, and 8. These are your noble gases. They have 8 in their outermost shell. They're happy and non-reactive. These ones, though, have 7 in their outermost shell. Therefore, they really want that other electron. So they generally go nicely with something over here, the alkalis. So you're going to do a little exercise similar to this where you are coloring in your periodic table and making sure that you understand the differences between a group, which is going up and down, and periods, which are going left to right. Okay, so here we would have period 1, and then period 2, and you just keep on going, period 3, period 4, period 5, period 6, period 7. And one other thing that you should probably understand here before we wrap up this introduction to the periodic table, if you have these groups which are going up and down and you have the periods which are going left and right, the ones that are going up and down here, these different columns, they are generally similar in reactivity because of the way that their outermost electron behaves and reacts with other elements. So you've probably heard of chlorine and bromine, and they're used as disinfectants. Iodine is also used as a disinfectant in the hospital setting. And whenever you're over here, these, like I said, they all are pretty similar in the way that they react with water. And then these ones are also similar in their chemical properties. So generally speaking, the valence electrons will indicate how they will react with other substances. Now our next objective is to look at periodic law, and the periodic law states that if elements are arranged by atomic number, then there will be repeating patterns of the properties of elements as we had just discussed. So I think that all of you are pretty clear that you understand that the periodic table is arranged by increasing atomic number. We have discussed that with a lot of depth in the last unit. So as I had mentioned earlier, one more time, if you see that elements in the same group do have similar physical and chemical properties, and this has to do with the valence electrons in their outermost shell. We can use the periodic table to determine the number of electrons available for bonding. So if we were to take, let's say, selenium and calculate their valence electrons, we can go back to the periodic table here, set back, and then locate this on the actual periodic table, which is right here. And we notice that it's over here in group 6. So it will have 6 electrons in its outermost shell. Once again, we count 1, 2, 3, 4, 5, 6, 7, 8. Yes, we skip all of this because they have special arrangements that we talk about later on. But generally speaking, whenever we're talking about valence electrons, we can easily predict these group 1, 2, 3, 4, 5, 6, 7, and 8 by their valence electrons. And let's go look at strontium, which is at 38. So let's look over here. Here's strontium. And we notice that it is number 2. So it has 2 valence electrons. Okay, now at this point, what I would like you to do is go under the modules and locate the alien lab little activity. You can work with 1 or 2 other people, that's fine. You're just going to have to find somebody that is at the same point that you're at. If not, you can work on it alone. It's not a big deal. Whenever you finish coloring in your periodic table and whenever you finish your alien lab, please send the alien lab through the Canvas box. I will not be grading these. I will be checking them for completion, but it's just a little fun activity to make you feel like Mendeleev probably once felt. Be on the lookout for the future vodcasts, which are going to be titled Electron Configurations and Periodic Trends. And you'll have some follow-up associated worksheets for each one and perhaps like a little lab activity. So be on the lookout for those. Keep progressing through at your own pace. And whenever you are finished with everything, let me know and you can go on to your test at the very end.